Welcome back to Mysterious Universe, where we uncover the deepest secrets of our planet and beyond. Today, we're diving, quite literally, beneath the thick, frozen veil of the most mysterious continent on Earth, Antarctica. You might think you know this land of ice, but trust me, what lies beneath could shake your understanding of the planet we call home. Antarctica has long been a blank spot on the map, hidden under an ice sheet so thick, so ancient, that it's kept its secrets for over 34 million years. But recently, a groundbreaking high-resolution topographic map released by the British Antarctic Survey revealed something jaw-dropping: towering mountain ranges, deep rift valleys, buried rivers, and subglacial lakes, all hidden beneath miles of snow and ice. But there's more. Scientists are now uncovering over 100 volcanoes buried beneath West Antarctica. Yes, volcanoes. Many of them still active. And while this may sound like science fiction, the implications are very real. Because when volcanoes meet ice, the outcome isn't just melting, it's the potential for rapid sea level rise, global climate feedback loops, and maybe even signs of ancient life hiding in alien-like subglacial ecosystems. So today, we're going on a journey through Antarctica's secret underworld. We'll explore the volcanic zones that could destabilize the ice sheet, the massive lakes of liquid water locked under kilometers of frozen crust, and even examine the unsettling possibility that eruptions, once thought dormant, might be awakening. We'll also uncover how octopus DNA is helping scientists piece together the history of ice collapse, and ask the ultimate question: is Antarctica's future more dangerous than we've been told? If you're fascinated by geology, climate science, ancient ecosystems, or simply crave answers to Earth's most chilling mysteries, this is the episode for you. Stay with us as we unravel the silent, fiery force threatening the stability of our world. And before we dive into the ice, make sure to like, subscribe, and hit that notification bell so you never miss another story from the hidden corners of our universe. Let's begin. When most people think of Antarctica, they imagine a frozen wasteland, desolate, cold, lifeless. But underneath the vast West Antarctic ice sheet lies something no one expected: a massive volcanic region. In fact, it may be the largest volcanic region on Earth. With over 100 volcanoes identified so far, most buried beneath up to 4 kilometers of ice. Unlike the Pacific Ring of Fire, these volcanoes are part of a rift system, where the Earth's crust is stretching and thinning. This geological activity creates magma chambers just below the ice. If even one of these volcanoes were to erupt, the consequences could be catastrophic, not just for Antarctica, but for the entire globe. Why? Because volcanic heat from below could rapidly melt the ice sheet from underneath. That meltwater would lubricate the base of the glacier, reducing friction and causing the massive ice sheets to slide into the ocean at unprecedented speeds. Scientists have long considered Antarctica geologically quiet, but this assumption is changing fast, especially as technology like ice-penetrating radar and satellite thermal mapping reveals hidden heat sources that suggest these volcanoes are not dormant, they're simply sleeping. And when they wake up, the ice will fall. Deep beneath the ice, nearly 2 miles down, lies Lake Vostok, one of the largest subglacial lakes on Earth. For millions of years, it has remained untouched by light, air, or surface life. But recent drilling missions have confirmed what few dared to imagine: living microbial organisms exist down there. This changes everything. We once thought Antarctica was devoid of complex life, especially beneath the ice. But now we know that entire ecosystems might be thriving in total darkness, feeding off minerals from the rock below and sustained by geothermal heat. It's a biosphere that exists outside the normal bounds of life as we understand it. More than 700 lakes have now been identified beneath Antarctica's ice. Some are interconnected by vast, hidden rivers. And these lakes may serve as analogs for life on Europa or Enceladus, icy moons in our solar system that may also harbor life beneath frozen crusts. But these lakes are more than just biological curiosities. They're critical components of the ice sheet's stability. As more heat reaches them, they could contribute to accelerated ice flow into the ocean, just like the volcanoes. This raises a terrifying possibility, a chain reaction. Subglacial lakes heat up and spread, glaciers speed up. More ice melts, and the feedback loop accelerates. The fear is not just one volcano or one melting lake. The true danger lies in a feedback loop that may already be underway. Here's how it works. Volcanoes erupt beneath the ice, generating heat. That heat melts the base of the ice sheet, forming liquid water. Water lubricates the ice above, causing it to move faster. The thinning ice reduces pressure on the Earth's crust, which may trigger more eruptions. More eruptions equals more heat equals faster collapse. This isn't just theory. Geological records show this cycle occurred before, in the Andes, during periods of rapid deglaciation. Modern modeling confirms it. When ice is removed quickly, volcanic systems destabilize. It's as if the Earth responds to surface changes from within. So as we continue to warm the planet, the very forces that lie dormant beneath Antarctica may begin to stir. The West Antarctic ice sheet alone holds enough water to raise global sea levels by over 5 meters. That's enough to drown entire coastlines, from Florida to Bangladesh. The worst part? Collapse may not be centuries away, as once believed. New studies suggest tipping points could be reached as early as the next few decades. The fuse is already lit. It sounds unbelievable. But DNA from tiny Antarctic octopuses may be one of the clearest clues we have that the West Antarctic ice sheet has collapsed before. Scientists noticed that octopus species living in the Weddell Sea and Ross Sea, currently separated by thick ice, shared remarkably similar genetic markers. This shouldn't be possible unless these two seas were once connected. Using molecular clocks and genomic sequencing, researchers dated this genetic mixing back to 125,000 years ago. During Earth's last interglacial period, temperatures were only slightly warmer than today. What does that mean? That during the last warm period, the West Antarctic ice sheet may have melted entirely, allowing octopuses to migrate across vast regions now separated by miles of ice. That same melting would have caused sea levels to rise by up to 10 meters, a level that aligns with fossilized shorelines found across the world. So if it happened once, it could happen again. And this time, we're the ones accelerating the process. These DNA clues offer more than just historical context. They serve as a biological warning system, a record of Earth's capacity for dramatic change in response to relatively modest temperature shifts. And if the octopuses are right, we may be standing at the edge of a familiar cliff. As global temperatures continue to rise and oceans infiltrate Antarctica's ice shelves, the ticking clock gets louder. The once ridiculed idea of volcanic activity reshaping the poles is now being taken seriously by glaciologists, volcanologists, and climate scientists alike. The physics is clear: as ice melts, pressure is released. As pressure drops, magma chambers expand, destabilize, and may erupt. Add in lubricated glacier beds and you get a highly dynamic, unstable system. This is no longer just a theoretical model. Satellites have observed thermal anomalies beneath the ice. Instruments are picking up tremors, microquakes deep beneath the crust. Seismic activity in one of Earth's coldest regions is increasing. And even worse, we're not prepared. Sea level rise won't just affect low-lying islands. It threatens global food systems, financial markets, migration patterns, and geopolitical stability. Major cities, from New York to Shanghai, face the risk of partial submergence. If we ignore these warning signs, the consequences will be far more expensive than any action we take now. Because in the grand equation of Earth's climate system, Antarctica is the final multiplier. One of the biggest challenges in preparing for Antarctica's future is predictive uncertainty. While we have incredibly advanced tools, from climate models to satellite observations, there's still so much we don't know. We don't fully understand how fast feedback loops will accelerate. We don't know how subglacial water will interact with volcanic heat in the coming decades. We can't yet model the tipping point at which collapse becomes irreversible. But that doesn't mean we're helpless. In fact, it means we must act with even greater urgency. Science isn't about certainty, it's about probability. And the probability of catastrophic sea level rise is growing. Every year we delay action, the window narrows. The decisions we make today will ripple far into the future, affecting not just our coastlines, but the architecture of civilization itself. That's why scientists continue to push for more research funding, international cooperation, and urgent climate policy reform. Because the story of Antarctica isn't just about the past. It's about what we choose to do next. The image of Antarctica as a static, frozen continent is an illusion. Beneath its icy surface lies a dynamic, volatile world, one that could determine the future of life on Earth. We've explored volcanic mountains hidden under miles of ice, vast rivers and lakes that shouldn't exist in the coldest place on Earth, and living organisms that thrive in utter darkness. We've seen how ice and magma interact in dangerous ways, how octopus DNA told us a story of ancient collapse, and how modern technology is finally revealing the full scale of the threat. The truth is clear: Antarctica is waking up. And its awakening could reshape coastlines, displace millions, and transform the global climate in ways we can't yet imagine. But there's still hope. Because knowing the danger is the first step toward avoiding it. Science has given us the tools to observe, to understand, and, most importantly, to act. At Mysterious Universe, we believe that curiosity is power. That the more we explore, the more we prepare. And that knowledge, no matter how chilling, is always better than ignorance. So if you found today's journey eye-opening, share this video. Let others see what lies beneath. And subscribe to join us as we continue to uncover the universe's greatest mysteries, one story at a time. Because sometimes the most powerful forces are the ones hidden in plain sight. Until next time, stay curious, stay prepared, and stay wondering. This is Mysterious Universe.